In section 6.5, we're going to be using determinants and Cramer's rule to solve systems of equations. So first, we're going to evaluate a second order determinant. That is a determinant of a 2 by 2 matrix, 2 rows, 2 columns. Then we'll use determinants in Cramer's rule to solve a system of linear equations in 2 variables. Then we're going to learn 3 methods for evaluating a third order determinant, or a determinant of a 3 by 3 matrix, 3 rows, 3 columns. We'll do it by formula, we'll do it by cofactor, and then we'll use our calculator. Then we'll use those determinants to solve a system of linear equations in 3 variables using Cramer's rule. What's a determinant? A determinant is just a constant associated to a particular matrix. So let's say you have a 2 by 2 matrix, 2 rows, 2 columns, that is formed using the elements A1, B1 for the first row, and A2, B2 for the second row. The determinant of this matrix is denoted by that array of values, but with straight bars around those values, not brackets. So when you see brackets, that's a matrix. When you see straight bars, that means determinant, and it's just a number. To find the determinant of the matrix A1, B1, A2, B2, you have a simple formula. You take A1 times B2, so you multiply together the main diagonal. And you subtract from it the product of the other diagonal. So you're going to subtract from A1, B2, A2 times B1. So you're going to take a product of the other diagonal and you're going to subtract it. And that is the determinant of that 2 by 2 matrix. So we say that the value of the second order determinant A1, B1, A2, B2 is A1 times B2, subtract from that A2 times B1. So let's find the determinant of a couple of 2 by 2 matrices. So the first matrix we have is 10, 9, 6, 5. So the determinant, which we denote by using straight bars, is 10, 6, 9, 5. All right, to find that determinant, we're going to first multiply together the main diagonal. So we're going to multiply 10 times 5. And we're going to subtract from that the product of the other diagonal. Now it's very important that you remember that you're subtracting here. If you don't subtract, you're going to get the incorrect answer. You must subtract those 2 products. The main diagonal, then you're going to subtract from it the product of the other diagonal. We'll put that in blue. So that's going to be 9 times 6. So when you take those 2 products and then take the difference of those 2 products, we get 50 minus 54, which is -4. So the determinant of that matrix is -4. Let's find the determinant of this matrix. So we're going to write that as 2, 4, and -3, -5, using bars instead of brackets. So that shows us that we're taking the determinant, finding the determinant. That's going to be equal to. So we're first going to take the product of the main diagonal. So we're going to multiply 2 times -5. And then we're going to subtract from that the product of the other diagonal, which is going to be 4 times -3. And it's very, very important that you keep track of your signs here because you don't want to make a sign error. So what are we going to get? 2 times -5 is -10, minus 4 times -3 is -12. So we have -10 minus a -12 plus 12, or 2. So to find the determinant of a 2 by 2 matrix, probably the easiest way to do it is to use the formula. You take the product of the major diagonal, so from the upper left to the lower right, and then you subtract from it the product of the other diagonal, so from the upper right to the lower left. All right, how do we use determinants? We use determinants and Cramer's rule to solve systems of equations. So let's say I have a system of equations, 2 equations and 2 variables, x and y. The first equation is a sub 1x plus b sub 1y equals c sub 1. The second equation is a sub 2x plus b sub 2y equals c sub 2. Then Cramer's rule says that you can determine the value of x, the first coordinate of the ordered pair that's a solution of this system, by taking the ratio of 2 determinants. The numerator is the determinant of the matrix formed by C1, C2, B1, B2, or C1, B1, C2, B2. I should say it in rows, not columns. But I said it in columns kind of on purpose because look at that first column. The first column is formed by the constants. Now look at y. Y is the ratio of 2 determinants also, but look at its numerator. Its numerator is A1, C1, A2, C2. The second column is formed by the constants. Now let's look at the denominators of both of these. The denominators of both of these is the determinant A1, B1, A2, B2. That is the determinant of the matrix formed by the coefficients on x and y. So the denominator is the determinant formed by the coefficients, the matrix formed by the coefficients. But the numerators, look what happens. The first column in my 2 by 2 matrix in the denominator is the coefficients on the x's, A1, A2. But in the numerator, I've replaced that x column with the constants. In y, I've replaced the coefficients of the y column with the constants. So we give these determinants names. D, sharing issues. Let me share again. There we go. So D, we're going to give it a name, D, is the determinant of the matrix formed by the coefficients on the x's and y's. So looking at our system of equations, the first equation, the coefficient on x is a sub 1. The coefficient on y is b sub 1. The second equation, the coefficient on the x is a sub 2. The coefficient on the y is b sub 2. So the determinant of the matrix formed by those coefficients would be the determinant A1, B1, A2, B2. D sub x, we're going to label that with a subscript. The determinant D sub x is the determinant of the matrix formed by replacing the x column with the constants. So C1, B1, C2, B2. D sub y, that determinant is the determinant of the matrix formed by replacing the y column with the constants. So it's A1C1, A2C2. And from that, we can find x and y. X is the determinant d sub x divided by the determinant d. And y is d sub y divided by d. So we can find three determinants and find x and y from those three determinants. This method works very, very well if your x and y's are fractions. So either by using substitution or addition, you determine that you get fractions in your equations, then Cramer's rule works very well. Cramer's rule does not work if the determinant D, the determinant of the matrix formed by the coefficients on my x's and y's, are 0. If that determinant is 0, you can't divide by 0, so you can't use Cramer's rule. You would have to use some other method to solve that system. All right, let's use Cramer's rule to solve a system of equations with two variables and two equations. So I need to determine three determinants. The first determinant I need to find is the determinant of the matrix formed by the coefficients on my x's and y's. That's D. So D is the determinant of the matrix 5, 3, 4, -6. All right, I'm going to find that determinant. I multiply the main diagonal and I subtract from it the product of the other diagonal. And I determine that that is -42. The second determinant I need to find is d sub x. So what I'm going to do is I'm going to replace the first column in the determinant d with my constants. So I'm going to take that first column and replace it with my constants. And the second column is going to be the same. Now I'm going to find that determinant. So that's 12 times -6 minus 4 times 24. And when I do that calculation, I get -168. The last determinant I'm going to find is d sub y. And d sub y is the determinant of the matrix formed by replacing my y column with my constants. So my first column will be 5, 3, the coefficients on the x's, but my second column is going to be my constants. All right, so now I'm going to find that determinant. And I have 5 times 24, excuse me, minus 12 times 3. And my calculator says that 5 times 24 minus 12 times 3 is 84. So now I have the values for my three determinants. D is -42, D sub x is -168, and D sub y is 84. So we had D is -42, D sub x is -168, and D sub y is 84. So now I can find x by taking the ratio of the determinant d sub x over the determinant d. So that's going to be -168 over -42, and that is equal to 4. Y is the ratio of the determinant d sub y over the determinant d, which is 84 over -42, which is -2. So the solution to my system of equations is 4, -2, the ordered pair 4, -2. Now, in some instances, it's probably just as easy to solve the system using addition, I could multiply the top equation by 6 and the bottom equation by 4, add them together and eliminate y. So it might be easier to do this by addition. It works, like I said, particularly well when you have solutions that are going to be fractions. Cramer's rule works really, really well for that. All right, what if I have a system of 3 equations and 3 variables? If that's the case, then I'm going to have to find 3 by 3 determinants. And there are 3 different ways you can find a 3 by 3 determinant. First of all, you can use this formula. And I'm going to show you how to use this formula where you don't have to memorize it. Or you can use cofactors, and I'll show you one method of cofactors. The third way is to put the matrix in your calculator and let your calculator determine the determinant. In your matrix menu, in the math menu, number 1 is DET, that's determinant. All right, so let me show you how to get this formula without actually having to memorize it. It's actually quite a complicated formula to memorize and use, but if you use this method, it's quite easy to do. So I'm going to rewrite the first 3 columns. Now I'm going to repeat the first 2 columns again. So I'm going to write A1, A2, A3, B1, B2, B3. Now I can find the determinant of this 3 by 3 matrix by taking products. So I start in the upper left-hand corner, first row, first column, and I draw a diagonal. A1, B2, C3. So I take that product. And I continue drawing diagonals. So I start on the first row, second column, and draw a diagonal. C2. And then I do the same thing for the next one. And I add those 3 products together. And you'll see that's the first half of this formula. Now I'm going to go the opposite direction. I'm going to start in the upper right corner and go down diagonally. So I get B1, A2, C3. I repeat, A1, C2, B3, repeat, C1, B2, and A3. And these are the 3 products that I subtract. That's the second half of this formula. You see the first thing there is A3, B2, C1, and I just have it written in a different order, A3, B2, C1. It's the same thing. And then the second product, A1, C2, B3, is the same as their second product, A1, C2, B3. And then the third product is the same. So I add the diagonals that I've written in red, and I subtract the diagonals that I've written in blue. And it's really easy to do. The only problem with doing this is sign errors. You forget to subtract the stuff in blue. So what I do is I change the sign and I add. So when I take the product of the blue diagonals, I automatically change the sign when I take that product. Then I can add everything together, because subtraction is adding the opposite. So if I change the sign and add, that's the same as subtraction. Now, the other way of doing this is by cofactors. And we only show you one example of cofactors because you can do this on any element in the matrix and it can get kind of complicated, but we're just going to show you one because it's the easiest way to do this. is show you just one. So what you do is you expand about a column or a row. So what you do is you take A1 and you cross out everything in the row or column that contains A1. And that's the determinant you're going to take. So you're going to take A1 times B2, C2, B3, C3. Then you're going to take the next one, A2. You're going to cross out the column and row that contains A2. And what's left over, you're going to take that determinant, B1, C1, B3, C3 times A2. But the second one you subtract. So the first one is A1 times that determinant. Then you're going to subtract from it A2 times the other determinant. Then you're going to take A3 and you're going to cross out the row and column that contains A3. You're going to multiply A3 times the determinant that's left over when you cross it out, B1, C1, B2, C2. So this is another way of finding the determinant of a 3x3 matrix. And this is the most complicated way to do it, and it's the one that's fraught with the most chances of making sign errors in it. Okay, so here is the explanation for finding a 3x3 determinant using this cofactor method. All right, so let's find the determinant of a 3x3 matrix using the two methods that I showed you, the formula and then expanding about a row and column using cofactors. And then we're going to use our calculator. Okay, so the first method I'm going to use is the formula. So I'm going to write down my matrix. And I'm going to repeat the first two columns. And then I'm going to take some products. So I'm going to start in the upper left corner and draw a diagonal. So I get 2 times 6 times 1. That's 12. I'm going to write that down. Then I'm going to draw the next diagonal. 1 times 0 times -4 is 0. Then the third diagonal from the left down is 7 times -5 times 3. I'd need my calculator. Take my calculator out, multiply 7 times -5, multiply that by 3, and I get -105. All right, so now I'm going to start in the upper right corner and draw diagonals. So I have 1 times -5 times 1. That's -5, but I'm going to change the sign to +5. That way I can add it. Changing the sign, then I can add. Then I have 2 times 0 times 3, that's 0. Then I have 7 times 6 times -4. That's going to be -168, but I'm going to change the sign to positive, and then I can add it. So I got -168. I changed the sign. Let me write that down. I changed the sign of these so I can add. And that's what I do. I add these 6 numbers together, and that gives me the determinant. So adding them up, I get 168 plus 0 plus 5 plus 12 plus 0 plus -105. And when I add all those numbers together, I get 80. So that's one method of finding a 3x3 determinant. All right, the second method is to use this expansion cofactor thing. Okay, so let me erase what I've written here. So I'm going to use the same slide. Okay, so I'm going to expand about the first column. So what I do is I take the 2 and I'm going to multiply it by the determinant left when I eliminate the row and column that 2 occurs in. So I'm going to wipe out the first row and the first column. So I have 6, 0, 3, 1. Then I'm going to subtract. You have to subtract the second one. Let me erase that. I'm going to subtract. Now I'm going to go down to the second element in the first row, first column, -5. Write that down. And then I'm going to cross out that row and that column. And I have 1, 7, 3, 1 left over. All right. Now we're going to do the last element in that first column. That's a -4. And it's going to be times 1, 6, 7, 0. All right. So the determinant of that 3 by 3 matrix can be found by this product and addition and subtraction. So what do we have here? We have 2 times that determinant. We take 6 minus 0. That would be 6. Minus a minus is going to give me +5 times. That's going to be 1 minus 21. Minus 4 times, what's that going to be? 0 minus 42. So I get 30 plus 5 times -20. That's going to be -100. Maybe a little bit neater than that. -4 times -42. All right, so let me do those calculations. And I get, I can't multiply apparently. Someone out there is now yelling, but 2 times 6 is 12. And it is. So let me correct my mistake. 2 times 6 is 12. I don't know where the 30 came from. All right, so now 12 minus 100 minus 168, and I have another error somewhere here. That better be plus 168. Can she make enough mistakes on one slide? -4 times -42 is positive 168. All right. Does she have it correct now? Because it better be 80, hadn't it? 12 minus 100 plus 168. If I take my calculator out and do that calculation, it is 80. And again, did I say unintentionally correctly earlier that this is the place that I make the most mistakes, is using this method for finding the determinant. It's just, for me, fraught with places to make sign errors. So I don't normally use this method. I either use the first method, which we showed you, or I use my calculator. So let's use our calculator. What do you say? So we're going to put this 3 by 3 matrix in our calculator, and we're going to let our calculator determine the determinant. All right, so I'm going to share my calculator. And I showed you in the 6.2 video how to delete matrices. And I want to show you that again. So I'm going to go to my memory menu, which is above my plus, second plus, and I'm going to go to memory management, delete, enter, and I'm going to go to number 5, matrix, and I put 3 matrices in there, and I'm just going to hit the delete key and delete all of them. Delete, delete, delete. So now my matrix menu should be clear. All right, so I'm going to go to my matrix menu, and I'm going to go over to edit, and I'm going to edit matrix A. This is a 3 by 3 matrix. It has 3 rows and 3 columns. And then I'm going to input those values that I had in that matrix. So the first row was 2, 1, 7. The second row was -5, 6, 0. And the third row was -4, 3, 1. All right, so now I need to exit out of the menu by doing a second quit, getting completely out of the matrix menu. I'm going to go back in, and I'm going to, there you can see my matrix A that I just inputted. I'm going to go to math, and number 1 is determinant. What am I going to find the determinant of? I'm going to find the determinant of matrix A. 80, which is what I had found using the other two methods. So if you want to make sure you don't make sign errors, let your calculator find the determinants for you, which is what we're going to do on our example for solving a 3x3 system using matrices. So we're going to go back to the PowerPoint, and we're going to show you how to do that. All right, so if you have a system of 3 equations and 3 variables, you're going to find 4 determinants. To find x, you're going to take the determinant d sub x and divide it by d. To find y, you're going to take the determinant d sub y and divide it by d. And to find z, you're going to take the determinant d sub z and divide it by d. What are those determinants? Well, d is the 3x3 determinant of the matrix formed by the coefficients on your x's and your y's and your z's. D sub x is the determinant of the matrix where you replace the first column in D, the x column, with your constants. D sub y is the 3x3 determinant of the matrix formed by replacing the second column in D with your constants. Replace the y column. And D sub z, you replace the third column, the z column, with your constants. So let's solve a system. We're going to solve this system of equations using determinants and Cramer's rule. So I'm going to write down the 4 determinants that I need to find. I'm going to go to my calculator and put these 4 matrices in and find the determinants, and then I'll come back and find the ratios for x and y and z. So D is the determinant of the matrix formed by the coefficients on x, on y, and on z. Trying to write down a z. And I'm going to do a quick check and make sure that I have that written down correctly. It should be 3, -2, 1, 2, 3, -1, and 1, 4, 3. So it looks good. Now I'm going to take that matrix determinant D, and I'm going to replace the first column with my constants. Now D sub y, I'm going to take that determinant D, and I'm going to replace the second column with my constants. And D sub z, I'm going to replace that third column with my constants. Do a quick check to make sure that I did that correctly. Looks good. 3, 2, 1, 16, -9, 2, 1, -1, 3. That looks good. D sub z, 3, 2, 1, -2, 3, 4, and 16, -9, 2. Okay, so that looks good. So what I'm going to do now is I'm going to share my calculator, and I'm going to input these four matrices. Now, I actually like to write down on the piece of paper that I'm working on where I'm going to put this. Now, I've already put a matrix in A, so maybe I want to put D in B. So I'm just going to write that down, then I'm going to put that in B. And I'm going to put D sub X in C, D sub Y in D, and D sub Z in E. And that'll help me keep track of where I put things. All right, let me share my calculator. All right, so I'm going to go to my matrix menu, and I'm going to edit, and I'm going to put that matrix or that determinant D, I'm going to put that matrix in B. Okay, it's a 3 by 3. And I had 3, -2, 1, 2, 3, -1, 1, 4, 3. I'm just going to make sure that I've inputted that correctly. I'm going to check with my paper that I've written down the determinant, make sure that it's correct. All right, so now I'm going to get out of my matrix menu, and I can go ahead and input C, D, and E, or I can find the determinant. Let's just go ahead and do that. Let me exit out of here. Go back in my matrix menu, go to Math. I'm going to calculate the determinant of that matrix B. Go back in. All right, and I get 58. So I'm going to write that down on my sheet of paper. All right, so now let's find the determinant of that next matrix, D sub X. So I'm going to go back to my matrix menu. I'm going to go over to edit. I'm going to edit C. All right, it's a 3 by 3. All right, that was 16, -2, 1, -9, 3, -1, 2, 4, 3. Okay, I'm going to make sure that I have that inputted correctly. Just do a quick check. I don't want to make another mistake. It looks good. So I'm going to exit out of the matrix menu, and let's go ahead and find that determinant. So go back in my matrix menu, go to Math. Number 1 is determinant. I'm going to find the determinant of matrix C because that's where I put that. Go back into matrix, choose C, that's number 3, and I get 116. So I'm going to write that down. All right, so now let's put that D sub Y in our calculator. I'm going to go to my matrix menu. I'm going to go to edit. I'm going to edit D. It's a 3 by 3. I'm going to put that matrix in, 3, 16, 1, 2, -4. I made a mistake, didn't I? I think that's supposed to be -9. So I see that. I'm just going to go back and correct it. Use my left arrow and go back and correct that. -1, 1, 2, 3. That's why I always do a quick check to make sure that I have it inputted correctly. Just checking my paper, making sure that I have it in, and I do. So let's go ahead and find that determinant. So I'm going to exit by doing a second quit. Go back into my matrix menu, go to the Math menu. Number 1 is determinant, and I'm going to find the determinant of matrix D. So go back into my matrix menu. D is number 4 on my list. Enter, and I get -174, which I'm going to write down. Rather messily over here, but I am writing it down. All right, last but not least, let's put D sub Z in. Go to your matrix menu. I'm going to go over to edit. I'm going to edit number 5, matrix E. So 3 by 3. Okay, I'm going to input that matrix. Two, 3, -9, 1, 4, 2. All right, let me make sure that I did that correctly. All right, that looks good. So I'm going to exit by doing a second quit. Go back in, go to the math menu. Number 1 is determinant. Then I'm going to find the determinant of E. Go back to my matrix menu. E is number 5. And I get 232. So I'm going to write that down. All right, so let me go back to my PowerPoint. And I did somewhat messily write down those 4 determinants. D was 58, D sub x was 116, D sub y was -174, and D sub z was 232. And the nice thing about this, nice thing about using in my calculator is, did I make a multiplication error? No. Did I make a sign error? No. Which I did when I did this by hand. So for me, sometimes it's just nice to use a calculator, even if I do it by hand, to check whether I've made an error or not. All right, so now that we have the 4 determinants, D was 58, D sub x was 116, D sub y was -174, and D sub z was 232. I can find x, y, and z. X is D sub x divided by D, which is 116, divided by 58, which is 2. Y is D sub y divided by D, which is -174, over 58, which is -3. Z is D sub z divided by D, which is 232, divided by 58, which is 4. So the solution to this system of equations is the ordered triple, 2, -3, 4. So this is how we solve a system of equations using Cramer's rule. You first must find 4 determinants, and once you find those 4 determinants, you're going to take ratios of those determinants, and that will give you x, y, and z. And that concludes section 6.5 on finding the solutions of equations using determinants and Cramer's rule.